All right, Math 112, Chapter 2, Set Theory, Section 2, Subsets and Set Operations. So we learned a lot of vocabulary in 2-1. Now we're going to add on to that vocabulary. We're going to identify subsets, complements, intersections, and unions. This is going to be about the relationship of elements within a set and between different sets. What do they have in common? What is different? How do you organize and say and display what is in these sets? One way is to use Venn diagrams. So it's a very popular method. So subset. A subset is the number of sets that you can make from a set. And the number that is possible from the original set technically is 2 to the n power and is the number of elements in the set. So an improper set is actually what they call the set, another set with all the same identical elements, and this is the symbol. So if you had, look at this B here, there's a set B that has 3, its cardinal number is 3, so it has 2 to the third power. 2 times 2 times 2 is 8 subsets. And if you had another, let's say you have another, sorry, I'm writing it way at the bottom. I think you can still see this. Let me move it up just a little bit. If you had another set that was 1, 2, 3, you could say that F is an improper subset of B. Okay. A proper subset is anything that you would normally think. Parts of the B set. It contains any combination of them from the original set, but not all, because all would be an improper. So some, including an empty set. And like, here, so if G set was a 1 and a 2, it is a proper subset. So you could say G is a proper subset of B. If you have H is a 1, a 2, and a 5, that is not, so H is not a proper subset of B because it contains something else. You can say that they were equivalent but not equal because they had the same number of, their cardinality was the same, the same number of members. Okay, so here's another example. Here it says a set A is cold and fluid, has 2 members, therefore 2 raised to the second power, 2 times 2 is 4 subsets. So it would have 3 proper sets, 1 element each, and the empty set, and then 1 improper, which would be identical to the first, is considered also a subset. Okay, let's see. If that is 3, it has 8 subsets. Therefore, B has the following subsets. It has, you can put them in any order. It has a subset of 1, a proper subset of 2, 3, and then any combination, 1 and a 2, 1 and a 3, 2 and a 3. How many have I got? 1, 2, 3, 4, 5, 6, 7 subsets so far, and then the improper, these are proper. 1, 2, 3 would be considered a improper subset, so that is also a subset. So there's 8 of them. Okay. Universal set is all the elements in a given situation, always designated by a U. So if a subset is labeled with a U, is automatically assumed to be a universal set. So that means it has all of them. So in this box here, this would be a type of setup for a Venn diagram, whether it has 1 circle, 2 circles, 5 circles, whatever. The universal name of this set is all of them in here on a roster list. Let me put 1, 2, 3, 4, 5, 6, 7, 8. There are 8 members in that set. A contains what's in the circle, 2, 4, 6, 8. So there's 4 things. And not A, or what is in the universal set that is not A, 1, 3, 5, 7. Is it required to put them in order? No, but I like to make sure that I have them all. Okay, and if I just like start over here and start writing them down, I may come around and put the 1 again or something. So I try to not do that. So the complement of A is all in U except for the set of A, which is 4 of them. Okay. This one has 1, 2, 3 commas are required for 5. A is, notice that B is a set that's within, is a subset of A. So A does include everything in B, 3 different members. B is just the 1 and the 3. So B is a proper subset of superset A. That's another way to say that. Okay, so that's just page 1 on this video. We'll do the other pages on other ones.